Greetings. We're happy to have you with us today. And as you know, our subject for review and demonstration is fluid denture base materials. You also know that this has been one of the most notable advances in denture construction in recent years. That is the development of denture base materials designed to be poured into the mold, right? Fluid resin materials and the denture fabrication concept they made possible held out great promise. Significant savings in effort, time, and money were anticipated. There were great expectations for the new material. However, translating the potential into a practical and accurate technique has been another matter. And that's what this film is all about. Incidentally, my name is Hugh Wolf, and appearing in movies is not exactly my thing. A Gregory Peck, I'm not. And I may just get a little tongue-tied now and then. I hope you'll excuse these shortcomings because I do know something about denture construction. I've been a dental technician for over 20 years, and presently I'm director of Dentsply's dental laboratory department. So much for my credentials and apologies. Now let's get back to the advantages and disadvantages of the new denture materials. The reversible hydrocolloid investment materials have received attention in recent years, but because of their gel type of body, they tend to stretch and sag, permitting multi-directional movement of teeth and cast in the investment. They cannot be expected to routinely produce the accuracy of tooth position desired in the finished denture. The hydrocolloid technique is also fairly complicated. Instead of a conventional boil-out, these teeth must be removed and marked and cleaned and then replaced individually. This means lost time and the chance that the teeth could float out of position while the resin is being poured. What's more, if the teeth are pulled out of place during the cure stage by the shrinking resin, the result may be closed bites or malpositioned teeth. Regardless of these disadvantages, interest in fluid resin materials and techniques has not slackened. Instead, the demand has grown for a more workable system, one which would combine the reliability of conventional denture fabrication with the speed and ease of handling of the fluid resin technique. The research department at Dentsply International set out to create just such a system. A complete development program was initiated. Standards consistent with Dentsply's reputation for quality were established. Instead of building our system on existing investment and fluid materials, we undertook to create new ones, which would not be limited by the inherent problems of the old. 3 criteria were applied in developing and testing the new materials. They must be easy to use, they must require no elaborate equipment, and they must give top quality results. 5 years of painstaking research culminated in the unit of our Trupour fluid resin system. We believe it fulfills your demands and our standards. It will enable you to produce high-quality work more easily and quickly, and with virtually no equipment investment. The technique can be easily learned in a very short time, and the Trupour system can be installed without interrupting production. There are really 5 significant factors which distinguish the Trupour system: the special investment material, the newly designed low monomer resin, the very easy technique, the highly simplified low-cost equipment, and of course the most important, the very excellent results. Trupour investment material is unique. It's rigid and strong enough to hold the teeth in place. Yet it carves and it breaks away so easily that deflasking is literally a breeze. We call it soft stone. Because it grips the teeth firmly in place, there's no danger of closed bites which cannot be opened. Any adjustments necessary are minimal, can be accomplished quite easily. Soft stone requires no special equipment, and it gives superb reproduction of your most subtle anatomical details. Trupour fluid resin is not a cold cure product. It is a modified heat cure resin, and it's a long step ahead of ordinary resins. It's dense, strong, and homogeneous, with a significant reduction of the shrinkage factor. We can show you why with a very simple demonstration. The resin powder is composed of polymer beads in carefully graded sizes. Let these balls represent those beads. 1 primary bead in the center with up to 6 other primary beads surrounding it in a hexagonal pattern. The spaces between the larger beads are filled, densely packed with smaller, still smaller, and even smaller yet. beads filling the voids and eliminating the porosity of ordinary resins. This picture shows the actual powder magnified 100 times. You can see the hexagonal pattern and the closely packed smaller beads. In most fluid resins, the voids between larger beads are filled with liquid monomer, which characteristically shrinks during the polymerization process. Trupour's unique structure reduces the ratio of monomer to polymer, thus reducing shrinkage. Also, the Trupour liquid monomer itself contains a highly adhesive polymer, which produces an even more favorable ratio. The minimal shrinkage which does occur is concentrated in the large sprues. This is a typical Trupour denture. A close look at the feeler gauge shows an accuracy to within 5/1000ths of an inch, or 1/8 of a millimeter, a meaningful improvement over conventionally processed dentures. The translucent fibered pink material has the appearance of natural gum tissue. It is available in 3 shades to suit most patients, and many color variations are possible by blending combinations of the 3 basic shades. Trupour resin meets ADA specification number 12 for heat-cured resin on all of these points. In addition, extensive laboratory tests for bonding properties with plastic teeth have proven Trupour exceptional in this respect. This photomicrograph with 3,000 power magnification shows how Trupour resin diffuses into the ridge lap of the tooth and actually becomes a part of the tooth structure. The tooth or the resin will fracture under acute stress before the bond separates. With porcelain teeth, Trupour locks mechanically to pins and diatoric holes. One of the most important benefits of the Trupour fluid resin is its capacity for detailed reproduction. Even a fingerprint left on a wax sprue will faithfully be recorded in the resin. The beauty of the Trupour technique is that you really have nothing new to learn. It is directly comparable to conventional processing with which you are already familiar. It just takes less time and less effort with no new special skills to learn. It also requires practically no equipment investment, no heavy expensive metal flasks which need cleaning and lubricating after every use, no costly hydrocolloid conditioner, no special tools or paraphernalia. The simple 2-piece flask consists of a base and a collar which is stapled in place. It costs so little, but it's reusable. Trupour investment can be mixed in an ordinary plaster bowl, and the Trupour resin in a plastic beaker. The Trupour introductory kit provides you with all the elements you need: the simple flask, the investment powder, the resin powder and liquid, separating medium, bonding agent, measuring vials, and mixing beakers, even a stapler and rubber bands to hold the cast and mold together. The most important factor in the Trupour fluid resin system is, of course, the result. A finished denture of the highest quality, strong, accurate, faithful to your wax-up, yet accomplished with an ease and a speed never before possible. I guess by now it's obvious that we think we have a great system for you here. We're proud of it, and we want you to get the most you can out of it. But like anything else, it won't work efficiently if it isn't properly understood. So why don't we run through the procedures of the Trupour system, and I can point out some of the more important factors as we go along. Preliminary preparation for a Trupour restoration follows generally accepted lines, in that the tooth arrangement should be completed along with the wax-up. In addition, it would be helpful if a taper is incorporated into the base of the cast. This will help when the cast is to be removed from the investment later on. The cast should be positioned on the base so that the teeth or wax-up are approximately 1/4 to 1/2 inch from the edge of this first step. This will lengthen the sprues as much as is practical. The cast is attached to the base with beading wax. You can use boxing wax or sticky wax, almost any type of wax which you feel that you'd like to use. The purpose of this wax is merely to hold the cast to the base so that it won't float or move when the investment is poured in. Next, we attach the sprues, and sprues are always attached to the highest or most distal portion of the wax-up when the case is held in a vertical or pouring position. Finger pressure will be sufficient to apply these sprues. They are cut off at a point directly above the first step on the base, and they are positioned so that they are in a horizontal or slightly tipped down position, pulled in towards the middle. The second sprue is attached in the center. All upper restorations need 3 sprues. Any restoration with a foot needs 3. However, this center sprue is not really a sprue. It's a vent to allow the escape of air. This shows 3 sprues attached to this upper restoration, a properly sprued upper denture. On the other hand, lower dentures and most partials only require 2 sprues. Either sprue may be used as a pouring sprue, the other one will automatically act as a vent. Next, we attach a collar, and that collar is simply wrapped around the step on the base, held firmly with finger pressure until we can put 4 staples in it. We can also snug up the base of the collar so that we'll get no investment leakage with a firm rubber band. This is an example of a case that has been flasked, ready for investment. The correct volumetric proportions for Trupour investment are 2 parts of powder to 1 part of liquid. This larger beaker is filled to the 12 fluid ounce mark with powder. The smaller beaker is filled to the 6 fluid ounce mark with water. Add the powder to the liquid and allow the powder to soak in slightly. This amount of powder and liquid would be sufficient to invest the average complete upper denture. And incidentally, this mixture will be much thinner than is normally employed. These materials will combine very easily, and they should be vigorously hand spatulated until lump-free. This material may be mixed by hand, it may be mechanically spatulated, and it may also be vacuumized. The material is then poured into the collar, the flask, the sprue area until the teeth are covered by 1/4 to 1/2 inch of investment. A few extra seconds of vibration to allow the air bubbles to escape from the mixture, and this then sits on the bench for 15 minutes until it is set up. After the material is set, the collar and base are removed in preparation for boil-out. By the way, if you find it necessary to interrupt the production schedule at this point, it's a good idea to wrap the investment in wet towels to maintain the moisture content of the investment. After the collar and base have been removed, there are 3 things to do to the investment. 1, free the base of the cast so that we can get a hold of it later on during boil-out. This groove around the base of the cast will be automatic if beading wax is employed. If sticky wax has been employed, it may be necessary to carve a groove around the base of the cast. Secondly, open up the sprue holes so that we can pour the resin in after the case has been boiled out. And thirdly, on the side opposite the sprue holes, on the back side of the investment, cut a flat spot so that the investment will stand upright in this manner. Now we're ready for boil-out. Submerge the invested wax up in clean boiling water for a period of 8 minutes. This will allow you to easily remove the stone cast. After the 8-minute interval, remove the investment from the boiling water and tease the cast out of the investment. Remove most of the softened wax and carefully rinse all of the residual wax from the cast. Then thoroughly scrub it with a soft brush and a detergent powder. Rinse away all traces of the detergent with water. This rinse should be carefully done because cleanliness is important for a good bond. The importance of removing all traces of wax and detergent from the mold and teeth should be emphasized. After all, any material left on the tooth surface acts as a separator, a film interface, if you will, between the tooth and the base. Residual wax or detergent film can prevent the teeth from bonding to the base, and you're quite likely to wind up with pop-offs. So care should be taken with this cleaning and rinsing of the cast and mold. For the next step in the procedure, the cast and investment should be as clean and hot as possible so that a good chemical reaction can occur between the separating medium, the cast, and the investment. Trupour separator is designed specifically for use with the Trupour system. Dispense an ounce or two into a cup, and by the way, you should never work out of the supply bottle, nor should you ever return any used separator to the supply bottle. As soon as the visible moisture has drained or evaporated from the cast surface, flood or generously paint the surface of the cast, including the land area, with the separator. After the cast has been flooded or liberally brushed with the separating medium, it should be rinsed with a rather gentle stream of water. A stream of water trickle down over your fingers to shield and protect the film on the cast. After rinsing the cast, set it aside in a vertical position to drain and dry, and apply separating medium to the mold. Generously flood or paint the separator into the mold, making sure to coat the inside surfaces of all sprues. After flowing the separator throughout the mold and sprues, allow the excess to flow off, then rinse the mold and the teeth in this gentle stream of water, and finally, both the cast and mold should be set aside to stand vertically to drain and dry for at least 10 minutes to toughen the separator film. After the draining and drying period, you're ready to submerge both the mold and the cast in a cold water bath, about a 60 to 65 degree temperature, to chill the mold and the cast. Your next step will be to remove the cast and the investment from the cold water bath and allow them to drain free of surface water. After removal from the cold water bath, care should be taken to remove water from the diatorics of porcelain teeth. This may be done by blotting the teeth with the cotton swab, or a very gentle stream of air may be employed to blow the water out of the posterior teeth. At this point, we also apply bonding agent to plastic teeth. Only a very small amount of bonding agent is required to achieve a good bond. The Trupour bonding agent may also be used on porcelain teeth. Now, the cast is reassembled into the investment, and the taper on the base of the cast acts as a guide, a seat, and a seal. The cast retaining cap and rubber band, which is included in the introductory kit, is attached to the investment, holding the cast firmly in place. And now we are ready to mix and pour the Trupour fluid resin. Individual mixing vials are furnished with the Trupour kit, and in these vials we will measure out 28 milliliters of powder and 13 milliliters of liquid. This powder measurement is a volumetric measurement, so the material should not be tamped down in the vial. The liquid measurement should be made carefully, and since the top of any column of liquid is a curved surface, that curved surface is called a meniscus, The bottom of that meniscus should be at least level with and perhaps a little above the 13 mark on the vial. This amount of material is sufficient for the average size denture. We combine the materials in the mixing cup provided and mix gently to avoid including air in the mixture. The mixture may be mixed for as long as 15 seconds, and it may bench set for as long as 15 seconds to encourage the release of air bubbles. When we begin pouring the mixture, the mold should be held at about a 45-degree angle and rotated 10 to 15 degrees. The mixture may be swirled, again, to promote the escape of air bubbles, and we begin pouring the mix slowly but steadily down one of the outside sprue holes. When the mold is approximately half filled, then we stop pouring and raise the mold into as nearly a horizontal position as we can, and then rock it gently to the left until the material almost flows out the left side. Rock it back gently to the right. This action can be repeated to flow the material throughout the mold, over the teeth, through the diatorics, and out the vent holes. This is to permit the release of any air bubbles entrapped within the mold. Return to the original pouring position and fill the mold up. The filled mold then sits on the bench for a period of 3 to 5 minutes, again to allow air bubbles to escape. While we're waiting for this 3 to 5 minute bench set, let's get back to a quick review of some of the more important points. Air inclusions can occur in the resin mixture because of the mixing technique and also in the pouring technique. However, these air inclusions can easily be eliminated with a few simple precautions. The less air you include during spatulation, the better. Whipping the mixture produces air bubbles. Now, this is fine if you're making an omelet, but it's bad news for fluid resins. So, quickly but gently does it. You've got about 15 seconds allowable for mixing. Then, the mixture can be allowed to stand for another 15 seconds, all for the release of air bubbles. So you see, the time factor does become fairly important. This is not the time to start a discussion on politics or about your mother-in-law. Polymerization starts the moment the powder and liquid meet. This polymerization action is continuous, and in a relatively short time, the mixture will begin to thicken. So, begin pouring as soon as possible. You'll have ample time to fill the mold. Just don't go answer the telephone. Now, you remember when I showed you the pouring technique. The flask or the mold was held at about a 45-degree angle to the operator, rotated slightly, and the mold was filled only about halfway. Then the mold was elevated into as nearly a horizontal position as possible and rocked gently back and forth to flow the resin throughout the mold. This is important because the viscosity of the resin may entrap air in the mold. Heavier liquids do tend to entrap air. For instance, this liquid, as it meets the barrier in the center of the dish, it flows around that barrier, leaving a pocket on the far side. But that pocket is removed by simply reversing the flow of the liquid in the dish. The same thing tends to happen when resin flows around teeth in the mold. So remember to rock the flask partway through the pouring operation. Then, when the pouring is complete, let it stand, let the flask stand so that entrapped air can rise out of the mold. Now let's go back to our demonstration at this point. The filled flask has now bench set for 5 minutes, and we're ready to complete the cure of the material. The flask is immersed in 140-degree water to within 1 inch of the sprue holes. Pressure pot is closed, and we process with 20 pounds of air pressure for 30 minutes at 140 degrees Fahrenheit. We do not recommend processing at 150 degrees or higher because porosity may develop. After processing, the denture is removed from the pressure pot and submerged in room temperature water to cool for 10 to 15 minutes. After removal from the water bath, the investment is very easily removed with a plaster knife by simply scoring the investment and breaking it away with hand pressure. Note the clean condition with which the denture comes out of the investment. Palatable sections lift out very cleanly, and any residual material that remains can be scrubbed away with a simple brush, plain soap and water. Following cleanup, the sprues are removed. And then the cut areas are trimmed in preparation for remounting. Normal finishing procedures such as spot grinding and milling may be completed before separating the denture from the cast for trimming and polishing. By the way, you'll find that Trupour resin polishes to a high luster quickly and easily. And here you have it. A beautiful denture. It's strong and dense with well-bonded teeth and a natural appearance. And it was so easy to make. Just bear in mind a few important factors and you'll soon be at home with the system. Now, one more time, let's quickly summarize. Avoid interface by careful cleaning and rinsing. Stir the resin mixture gently to keep out the air. Pour the resin carefully and rock the flask to prevent bubbles. Keep an eye on the clock during the mixing, pouring stages. And watch the curing pot temperature and pressure during the curing cycle. That's it. It won't take long till you're very comfortable with the procedures and you'll be able to process several dentures at a time, several times a day. Okay? Now I'd like to make just one more point. The benefits of the Trupour fluid resin system are not limited to the construction of complete dentures. The pouring and processing procedures for removable partial dentures are basically the same as those already demonstrated. When making partial dentures, rebases, relines, repairs, or temporary restorations, you'll find that in addition to the speed and ease of handling which is built into the system, you'll appreciate the accuracy of Trupour restorations. If you're making partial dentures with precision attachments, this accuracy is especially important. Remember, the physical properties of Trupour resin assure a very low percentage of shrinkage, and the forces of compression packing are eliminated. So there's no binding, warping, springing pressures applied to the metal frame with the Trupour system. These concerns are eliminated and can be completely forgotten. You'll find that your carefully constructed, accurately finished metal frames will fit better than ever before because of the no-pressure technique of the Trupour system. Incidentally, you don't have to memorize everything that I've said on film today. Complete illustrated instructions are provided in the introductory kit. If you follow them, you can't go wrong. Yes, for high-quality complete dentures and for precision partial dentures, the Trupour system is your answer. We believe our system will serve you well. In today's economy, fast, efficient production is important, but it is still more important to maintain a high standard of quality. The Trupour system will accomplish both for you.